All right. Good morning, everybody. How you doing? Thanks for jumping on the stream. Was quiet last week on streams. Not quiet work-wise. Trend Micro had made a big acquisition, which was fantastic, but that kept me slightly busy last week, so I wasn't able to jump on the streams. Let me just double-check the quality here. Everything's looking good. We are 5x5. Awesome. All right. So we're live here on LinkedIn. We're live on Periscope through Twitter as well. LinkedIn is the easiest place for comments. So I've got it up. I can see it as we're going along and I'm showing you other things. So if you have some questions as I'm going along, it's absolutely the best time to ask them. I will cover them after the fact as well. I always go through to see if other people have added additional comments over time. But definitely, ask them here on the LinkedIn stream. I will do my best to fire them off from Twitter as well. Twitter should be a little bit better, but of course I turned off notifications because I didn't want the stream to get disturbed. It's one of those sort of catch-22s. So I also realized that I'm totally going to have to update that graphic, that nice picturesque fall graphic for Road to Reinvent, because I certainly don't have any leaves left on the trees around my neck of the woods. It was a beautiful fall, but it is quickly switching into winter, which is sort of a Halloween tradition. Up here where I live in Canada, inevitably every kid comes dressed as the same thing. Something underneath the parka, because it's cold and sleet and icy rain or snow starting off on the day. So today what we're going to talk about is AWS database service offerings. So let's dive right in. Let me share out my screen. We are going to go Google Chrome, databases on AWS. Perfect. So let's make that a little bit bigger so you guys can see it. So there is actually a database page for AWS now. They make this a little bit easier and they say, hey, like here's our databases. Here's what we've got to offer you. Let me pull up the countdown clock too. Because this is a key part of the AWS offerings. And in fact, every year at reInvent, what we see is Werner will get up on stage and talk about how they are expanding their database offerings and all of these different services that give you, purpose-built databases. They say it's 14, which is relatively true. There's a little bit of stretching in there, but they do have a wide variety, far more than most other cloud providers. And they are all really high-end, which is great. But they do have some differences, and that is absolutely important to understand. So they have a breakdown on this webpage. So this is, if we look, we go to Amazon, aws.amazon.com/product/databases. I'll actually just drop that in the chat for you guys. There we go. So that's the official database page from AWS. But we're going to go into what these actually mean. And essentially, there's a whole bunch of different use cases positioned on this page, which is great. But they all bubble down to storing data and being able to query it. So we already saw a very unique database structure when we did the episode on streaming S3, or the streaming episode when we talked about S3, then when we talked about Athena. That is a way where you can query some data as well and treat it like a database, even though it's flat file storage. That has some really unique applications. But today we're talking sort of more traditional, old school database concepts. And with that end, let's start looking at this. So this is a set of slides I whipped up for today. Wanted to walk you guys through this. There are three major offerings and a tool under the category of relational databases. Okay, so relational databases are what you would traditionally think of as a database. They store data in a table, and you can query them out. So in this case, we have Amazon Aurora, which is a truly cloud-native, scalable, ridiculously low-cost, really, really high-end relational database service. And you know what? By default, you should just be on Aurora. There are Postgres and MySQL accesses into Aurora. There is even a serverless version/feature in Aurora to make it easier to access from AWS Lambda and serverless designs. But realistically, if you're doing a traditional database structure, Aurora is where you want to start. That is the most logical place. It lines up sort of that best balance of I'm comfortable dealing with traditional SQL. I can get it out through two very popular standardized open source interfaces, Postgres and MySQL. It's really takes advantage of that, the fault tolerance in the cloud, the scalability in the cloud. It is a managed level service, which is great. Amazon Redshift is their database warehouse. So sort of old school database warehouse application. Scales really, really big. If you have traditional sort of batch database processing, this is a great call. And then RDS is sort of the catch-all for everything else. If you need a MS SQL database, if you need an Oracle database, if you need old traditional Postgres or traditional MySQL or MariaDB, this is where you get it. So start at Aurora. If you can't go Aurora, you tend to end up in RDS. And then I wanted to call out the specific database migration service. Basically, database migration service will let you move between any of these three other services, but also importantly on-premise stuff. So if you have a database on-premise that's running like Microsoft SQL, you can actually use the database migration service to move everything, your data, your triggers, your functions, all that stuff over into like Aurora, and it'll do the conversions as necessary. Fantastically useful service for 1 or 2 times. Can be used, to move data from production, from dev and test into production. You really want to be careful moving production data into dev and test, but very useful to migrate from point A to point B, and point A can pretty much be anywhere. So that's traditional relational databases. I think all of us are very comfortable with that. I didn't want to spend too much time. What I did want to do is introduce the next type of database, and this is Amazon's Document DB. It's based and is fully MongoDB compatible. And essentially, you're storing documents and querying based on any property in those documents. So a document in this case is a collection of key value pairs. So you can have, title equals AWS databases, author equals, Mark Nunakoven, content, and then a big blurb of text, whatever you need. So very free form, NoSQL. So that's refers to a type and style of database where it's very much off to the sort of up to you as the user to define what goes in there. Traditionally, they don't have schemas, which is a data definition. And then you can query as is. Very handy, very useful in a lot of scenarios, especially mobile applications. So that's Document DB. Next up, and we're going to dive into this more in a few minutes, is Amazon Neptune, which is a graph database. Graph database is really good for tracking relationships. Now, I know what you're going to say. You're going to say, wait a minute, didn't we just talk about a relational database category? Yeah, we did. Graphs are actually far better to track relationships and properties according to those relationships, and I'll show you why in detail in a second. But Amazon Neptune is the offering from AWS there. I was a little bit disappointed in that it's a traditional sort of instance-based offering, so you still have to stand up an instance. Same with Document DB. I would like to see these be moved more into the serverless world, but baby steps, we're getting there. Last up in this column is a ledger database. Please don't even get me started on this. I guess I have to define it. Fine. It's a blockchain-based ledger database. It's called the Amazon Quantum Ledger Database. It's best if we just move on. Extremely limited in its use cases. If you have one of these use cases, extremely useful. It is immutable ledger, so you can't change things. Things sort of like a double entry accounting. You can't remove something once you put it in there. You need to make a counter entry. Very useful in its very limited use cases, but a lot of people try to shove a lot of stuff that doesn't belong into a ledger. But we'll tackle that another time. Time series, new last year at reInvent, along with Neptune, was Amazon TimeStream. That is an extremely powerful database if your data is based on a time series. So if you're tracking things like events, if everything has a timestamp to it, time series might be where you want to go, depending on the type, what you want to do with that data. Finally, we have key value, Amazon Dynamo DB. This is going to be the number one workhorse outside of relational databases for most of us, and we'll actually dive into that console in a minute. Though it's been a long time since I played with Dynamo DB, so bear with me, but yeah, we'll get some hands-on experience in this stream with that one. And the last database rounding it out is the in-memory databases. These are Amazon Elasticache. You have a memcached version and a Redis version. Very, very fast, very, very powerful if you want an in-memory database. So that's the breakdown of the database offerings. Lots of great power here, and you may be thinking, which one do I use and when? The number one thing you need to think about is, well, there's 2 stages to this basically. Think about, are you going to be writing to the database or reading to the database more? And then based on that, next question, how are you pulling data out? Like, what do you want to do with this data? And that's absolutely critical. So Document DB we see deployed a lot of the time for mobile applications where you need to send a chunk of related information to a mobile client with one query. So you're trying to reduce network back and forth. So you just say, hey, give me today's episode metadata, and there you get it all in one query with one quick lookup. Relational database has been around for 40 plus years. It's well known as far as its sort of edge cases and how best to design and set things up. But yeah, taking your data out is the absolute sort of most critical thing to think about, and that really will tell you what you're going to be picking. So I would highly recommend spending more time writing data or writing actions on your side that put more work on you to write things in a data format or in a structure that makes it easier to pull out. Because that's the majority of most database usages, is actually querying the data and pulling it out. So let me walk you through a very simple example. Let's look at a traditional relational database setup. So here we have 3 tables, very simply. We have names, so I'm there, a bunch of fake names are there. We have buses, so these would be a bus route. So bus route 1 would go from the airport to the hotel. Bus route 2 goes from the hotel to the office. Which is great, right? And then we have a table that helps connect these. So to say who has ridden on what bus. So if we look at my ID, my name ID is 1. If we look in names to buses, name ID 1 rode bus 2. So I went from the hotel to the office. Name ID 1, that's me again, rode bus 1. I went from the airport to the hotel. Right? So that's how we connect these 2 pieces of information. I'm tracking in the names table, I'm tracking all the people I know about, all my bus riders. In the buses table, I'm tracking all my bus routes. And then I've created this new table called names to buses that links these 2 to make it possible to query to say how many buses, which buses did Mark take, or which riders were on this bus. You can go either way. And what ends up happening is you write a query that looks kind of like this. Right? So this is a standard relational database query written in SQL. I'm just double checking to see if there's any comments on Twitter. So again, if you have questions, guys, while we're going through this, ask them in the comments in LinkedIn or on Twitter, and that's great. You can ask them after the words as well. But if we have our standard relational database query, it does break down to somewhat English-ish. It's not that hard to understand, I think, when you break it down. So select, so give me, star is everything, from names. Okay, that makes sense. Give me everything from names, and I'm going to call names N just to make it easier. So instead of typing out names, I just use the letter N. Inner join, which means connect these 2 tables. Names to buses, and I'll call that N to B. On NID, so name ID, and names to buses, name ID, right? That makes sense. I'm linking up the same thing. So I'm saying in table names, there's a field called ID. In names to buses, there's a field called name ID. And when those 2 things are the same, connect those 2 tables, all the values in those 2 tables. Furthermore, here's another inner join. Furthermore, connect the table buses, which we're just going to refer to as B because it's faster than typing out buses. On the bus ID, when it's equal to names to buses, bus ID. Right? That makes sense. So what I'm saying is give me everything from names. So say Mark Nunakoven. Every time that you see that name ID in the names to buses table, and then also grab me the buses information when the bus ID equals the same bus that's in the names to buses. So what that effectively does is connects these 3 tables by saying when Mark Nunakoven, so when I have an ID of 1, here in my names to buses, I have an ID of 1 and then a bus ID of 2, grab that, right? And then for this second row, I'm going to get another entry where it's Mark Nunakoven, 1-to-1, airport hotel. So there will be, in the result of this query, I'm going to see 2 rows for me, 1 for each of the bus rides I took. That is almost standard, literally textbook SQL, and it's clunky as all get out. It works, but if you start to expand beyond multiple relationships, so this is a second order relationship, we have, or a first order relationship, we have names to buses, and that's what we're connecting. If you start to do second and third order relationships or n order relationships, it gets really bad really fast. You get these monstrous queries, you make these tables more than these kind of names to buses tables, you have these odd connection tables, all to try to create these relationships. And yes, it is a relational database, but I think if you've been building anything for any length of time, you know that database technology like this gets used and abused in any number of ways that don't make sense. Now, if we take this concept, this exact same concept, we're going to look at how a graph database would store it. So in this case, Amazon Neptune. We've got the exact same information here, but I think right off the bat, visually, you as a user understand this far better, right? We have our riders on the outside in the blue balls, and in the green circles, we've got our buses, right? So blue circles are riders. Excuse me, my allergies are killing me this week. And then in the green circles, we've got our bus, and then we have relationships. Now, all these lines, I just colored them differently to make it easier to see them. But you'll see we have a relationship line. So Mark rides the number 1 bus, and that ride line is pretty thin because I've only done it once or twice. Mark rides the number 2 bus, but it's a big, thick line because I ride that bus far more often. Same with Jen in the opposite corner. She rides the first bus, quite a little bit more. Then she rides the second one. Orlean here only rides the 1 bus, and Walter has moderate rides on either. Now, this, as a graph database, it stores it in a whole bunch of really cool data structures in the back end that you don't have to worry about. Conceptually, you just need to think about this kind of graph structure that you see on your on the screen right now on this slide. Now, when we want to query this, the syntax is going to change depending on the graph database that you're working with, but the concept is all the same. So you see on the left-hand side here, the buses, this document structure, this nested structure, is literally a query in GraphQL. So I want bus, and I want the names of all the riders related to bus, first and last. That's it. That's a simpler relationship pull than than in a relational database, right? And graph queries can get really complicated really, really quickly, but in a positive way. They're always extremely understandable. Fellow AWS community hero Gemma Eileen Smith gave a great talk at the Public Sector Summit in DC. How she had helped an organization in New York using open data from the city make relationship connections between various actions. So when there was like a spike in parking tickets, connected that to 311 complaints and construction in the area, and it's far simpler. All store in a graph database, right? Because graph databases are all about relationships. Now that seems very backwards compared to a relational database and a graph database. You'd think relational databases are all about relationships, and they are, but you get clunky queries like this, right? It makes it very hard. You have to have additional tables to connect other tables to make multiple relationships between them. Whereas the graph database, and I forgive the rapid scrolling here, the graph database, you get this very logical structure. This is how you would draw it out if I said, draw this out on a whiteboard. Tell me who takes what bus. You would draw something far more similar to this rather than table after table after table of information. So this was just a quick illustration of why you would pick one database over the other. If we're trying to figure out bus ridership in an area, a graph database makes way more sense, especially if we start to add in additional data points, like places. So if we start to add in places, where did they get off on these bus routes, right? We could add in a place circle for the office, and then we could quickly see, well, who was getting off there, which bus routes were getting more service to each of these places when there was multiple routes in place. And it's just a far simpler way to understand. So that's Amazon Neptune, which is what I really hope they come out with a serverless version of it, because I don't want to manage instances, but that is the core difference between those types of databases. And you have to keep asking those similar questions when you're looking, when you're looking across these different options. Which one do you pick? It really depends on how you want to pull data out. What do you want to do with that data, right? You're never going to pick something like Amazon Elasticache for long-term queries. What you're going to pick Elasticache for is to speed up common queries and to shove things in. So really sits in front. These in-memory databases tend to sit in front of another database. A lot of the time, key value is what you actually want when you're trying relational database, and Amazon DB, Dynamo DB makes it really easy to do key value. So let's flip over there and take a look at that. So go back to my browser, get this out of my screen. So if I go to Dynamo DB, let me close out all these options. So if I go to Dynamo DB, and again, bear with me, it's been a really long time since I've done this myself in a management console. Fast and flexible, NoSQL database service. You create tables, add and query items, and you can monitor and manage those tables. Very simple, very straightforward. So we're going to create a table. We're going to call this Let's go same data. Buses. The primary key is bus ID, okay? And it's going to be a number, right? So we're also going to add a sort key, which is going to be place. So we have a table named buses. We have a bus ID. We are adding a sort key. That's our primary key. Our sort key is also going to be place. So we're going to sort out by that. And then we're going to use default indexes. Now, I don't have auto scaling enabled by default. That's a relatively new Dynamo DB service or feature, and you really should enable that. We don't have time to go through the documentation right now. Basically, what it allows you to do is let Dynamo DB throttle things for you automatically. That's fine. We're going to just click the blue create button, and this is going to create our table. So it's being created right now, which is great. So the idea here is that you don't want to actually end up connecting tables like we did in the SQL. So if we look at our overview, it's just been created. We don't have any streams. That's fine. We have no items. So we can start to add items. We could also add, so here we've got a bus ID, we've got a place. We can add our bus ID is 1, place is office. We can actually add another second stop. Attribute value is going to be hotel. So we can start creating our items like this, right? Standard sort of relational database. But you can start to get really complicated and actually add connections. So you can set it up like we did with a traditional database. So I can create a second table. I can create my names table. And my name is going to be first. And I'll add a sort key by last. That's fine. So that's going to create a second one. And what you can do here is, because of the way this works. Now, forgive me if I am breaking a lot of Dynamo rules, and I probably am. I'm not as up to speed on my Dynamo optimized structures that I should be. But if I take this, I can add a binary. Let's add a binary set. And I'm going to add rides. And in this case, what I'm going to do, yes, there we go. And then I add a second ride. You're probably wondering what I'm doing. Well, what I'm doing here, null or empty values. One or more parameter values are in, this is, you gotta love live streams, right? So my idea here is basically I'm entering me as a rider, and then within that record directly, I'm going to get that relationship of how many bus rides I've taken. So I'm gonna keep a binary set, which is just, oh, no, sorry, I don't want a binary set. That's the problem. What I want is a number set, not a binary set. Or a map. Let's see if I can get a map. Yikes. Let me kill this. Stop. Remove. There we go. Okay. Append. Number set. There we go. My apologies. So, number set. Append. There. 2. Perfect. So save that. There we go. Okay. So what I've done here is I've actually shrunk this down by a table to overall optimize this. So instead of creating multiple tables, I have a master table for my buses. So I've got a bus ID and a place and a stop. But also in my rider record, I am keeping track of rides. And that is because most of the time I want to know where my riders, multiple riders are taking similar buses, so that I can combine routes maybe later. But also possible to query based on the ride values to then line up to see who's taking the buses. One less table, but far more performant this way. And again, there's probably 6 different ways to design this in a different structure. But if I want to query this, I can do the same thing. I can write a simple query that goes across these 2 tables and essentially say, you know what, for rider Mark, I want to see what the bus rides are. Now, what I would do when I'm building an application is I would actually just query the buses, because I'd have a finite number of, I'd have much less routes than riders. So I'd query the buses, keep that in memory, and then just query the names and say, Mark, okay, he rode bus 2, what's that one? He rode bus 1, okay, great, what's that one? And then you could also, because this is a set, you could work over the set and say, how many times have I taken bus number 2? So if I change this record again, if I go into my rides, let me add there. If I go into my rides, I can add another ride on 2. I can add another ride on too. So now I've taken multiple buses. Of course, it's duplicates because I'm not setting this up correctly. But that kind of concept works similarly, right? So very rough example of how to use Dynamo, simply because I'm out of practice, which I apologize for, but you get the concept, right? We walked through, let me share that again real fast. We walked through some of the, and of course I closed it. No, there we go. We walked through some of the different types of offerings of databases. So if you're looking for relational database, so you're setting it up in tables, you want to be sitting in Aurora or one of the RDS variants, but try for Aurora as much as you can. If you have just a bunch of data that needs to stay together almost all the time, that's a document DB. Those graphs, if you're thinking of things like this, graph database, Amazon Neptune is the way to go. Avoid Ledger. If you need Ledger, you know it. Time series. Time stream's really intriguing to me, actually. I don't think it gets enough play. I think it's still in its early stages, but a lot of stuff that gets shoved into a relational database is really time series data. So if you have something that's explicitly time series and you're thinking about it in the concept of time, check out Time Stream. A lot of cloud native designs actually end up in Dynamo DB. Do not let my fumbling around it dissuade you. It is the best database service out there. I think, especially in the AWS cloud, it is quite powerful. There are some phenomenal courses out there on Dynamo DB, some great information, some people much better than I at it. And it's a great reminder that I just need to get my hands dirty a little bit more. I need to dive in. So that's a quick overview of the AWS database services. I appreciate you joining me here on LinkedIn. I appreciate you joining me on Twitter. Hopefully this has been useful. Please let me know if you have any questions, what you'd like to see in the next stream. That's probably going to be next week. I got a bunch of stuff that's due for reInvent this week, so I'm trying to get that out. Yeah, always appreciate your time, and let me know what you think. We'll talk to you soon. Thanks for joining.